A ray of light strikes a glass slab 5 cm thick, making an angle of incident equal to 30 degree. So you know what exactly happens in it. I can just roughly tell you and then move on from there. Fine, we'll draw the proper diagram later on. So say there is a ray of light coming and making an incident of how much? 30 degree here. Okay. Now, so this is 30 degree here. Obviously it is a denser medium, so it will bend towards the normal, right? And from there again it will bend away from the normal. Say had it gone straight, it would have gone like this. So we have to calculate the lateral distance also from there. So this is 30. We do not know what angle is this one. Fine. Angle of refraction. Draw the ray diagram to show the emergent ray and the refracted ray through the glass block. Refractive index of the glass is 1.5. This is 1.5 mu. Fine. So measure this lateral displacement. Okay, they have given the take sine 19.5 is 1/3. So we have to measure this distance. This is basically a diagram which you have to draw in it. So before we draw, we need to know what angle will it be. So remember, we have a formula that is mu glass is what? That is sine of angle of incidence, right, upon sine of angle of refraction. What is mu they have given you? They have given you 1.5. So I'll take it as 1.5 is equal to sine I. So sine 30, sine I means sine of 30 degree upon sine of angle R. We do not know. So if you solve it, what do you get? So 1.5, basically it is 3/2 is equal to 1/2 divided by sine of R. And you solve it, what do you get? It will be 3/2. Okay, let's move it like this. It will be sine of angle R is equal to 1/2, right? This will come here and it will come divided by 3/2. So sine of angle R is equal to 1/2 into 2/3. So sine of angle R is equal to 1/3. So they have given, and must be wondering why they have given you. They have given sine of what angle is 1/3? 19.5 degrees. So which means if it is 1/3, the angle must be 19.3. It is, we can write it as sine of angle R is equal to sine of 19.5 degree, right? So what is angle R? Angle R is 19.5 degree. Got the point? So that's the reason they had given you. So taking this 19.5 degree with the you can be able to draw with the protractor here, and you can further, because these two lines have to be parallel, you draw it, right? This angle also will be how much? 19.5 degree. This also will be 19.5 degree, and this will be how much? 30 degree. And you draw it, you will see it comes out parallel to this extended line, and you have to measure the distance from there. So first thing you have to calculate is the angle of refraction, and we have to calculate by using this method here. Okay, now if you say, I'll just put the picture of that particular figure here, so that drawing is a difficult task. So I'll just do it for you. Just put it there and see incident ray 30 degree, 19.5 degree I mentioned, you have to draw that. And again this also will be 19.5, this will be 30 degree, you draw that, it comes out, you produce this line and you measure the distance. Whatever the distance comes in, that is the lateral distance. You have to measure that part here. Is that okay? Fine, you have to measure that part here, and once you measure, okay, and that will be the answer they are asking for, because they are asking the lateral displacement of the ray also. So fine, this is how you have to do it. But before that, you have to calculate the angle R here in it.